called FTA. Now today in this video I'm going to describe FTA, fault tree analysis, and now we are going to draw the fault tree analysis. So let's see what happens in this FTA. We have not two gates, we have so many gates and so many things. Oh sorry, gates are only two. So we draw FTA, fault tree analysis, on the basis of two gates. That what are those? AND gate and the OR gate. So AND gate is being drawn like this, and we have x1 and x2, and OR gate is being drawn like this. It's a little curvy here, and here it is x1 and x2. So we have two gates in fault tree analysis, that is the AND gate and OR gate. So we draw fault tree analysis on the basis of these two gates, and you know that this is also the top down technique. Okay, and what we have for AND gate, we have x of a equals to I going from 1 to n x of I. So this is the formula for AND gate, that it is the product from I going from 1 to n and all the x of i's. And for OR gate, this is the formula for OR gate. How we can represent OR gate? X of 0, x of O equals to 1 minus the product from I going from 1 to n and 1 minus x of I. Okay, so this is the method of writing x of 0, x OR, and this is the formula for writing x AND. Okay, and this can be done in the form of like this: 1 minus x1, 1 minus x2 equals to 0. So this is the way of writing this x0, x OR. Okay, so in fault tree analysis we have two gates, AND gate and the OR gate, and they both have a formula, that is x of a and x of o. They are represented in the form of like this, and they have the property, the AND gate and the OR gate property, they are just the same for all x1, x2 and x of a. They are the same. For AND gate we have a combination, we have only 1 into 1. When both the x1 and x2 are 1s, then only we have an output of high. Okay, and when there is a single 0 in our inputs, so we have a low output. Okay, so this is the property of AND gate. Okay, simply in AND gate we basically multiply. 0 into 0 is 0, 0 1 is 0, 1 0 is a 0, and 1 1 is a 1. So we multiply all the inputs, we multiply the inputs, and we got our output, we got the result. So this is the property of AND gate. And for OR gate, what is our property? We have two inputs, suppose, and we have x of 0, x of o. X o is for OR gate, we have the property that only if we have one input as 1 and the other 0, so if we have only one input as 1, the output would also be 1. Okay, so this is the OR gate property. What it is, that if in the input we have one high, so the output would be high. Okay, it doesn't matter that how many lows are there, it doesn't matter, only if we have one high, so the output would be high. And in AND gate, what we have it is necessary for the output to be high if there would be all the inputs as high. Okay, all the inputs should be high to get a high output, sorry. Okay, so these are the properties. This is the basic thing, and I have explained it because it is necessary to start the fault tree analysis. I have explained this. So how we can draw our fault tree analysis? Let's see how we can draw it. Now it says that we have a top event. What is that? That failure of the system. Okay, we have a top event as failure of the system. And where is our system basically? Okay, first we are taking this parallels. We have just a simple system, a simple parallel. What is this? That here it is start and end, and we have A and B connected in parallel, and it is connected in series to C and D. So this is our parallel system. This is our parallel RBD. We have a RBD, and we have to draw fault tree analysis of this RBD. So how it can be drawn? First we have taken the example, simple example for our parallel RBDs and how the fault tree analysis can be drawn for this RBD. Let's have a look. So we have top event, that failure of the system. So how this RBD is going to fail? So here is start and end, and how this system is going to fail. What would be the how it can fail? So failure of the system, it is connected, OR gate is connected. Okay, and what OR gate, what are the possibilities? That we have either the failure can be of A and B. Okay, the first, this we say it as first parallel and we say this as second parallel. So what is the possibility that first parallel not working and second parallel not working? Because if we say that first, if suppose this parallel is not working, either this one is working but there would be no use of this working, because if this is not working there would be no output on the system, on the and our system won't work. Or the same way, if our this parallel is not working and this is working, so the input that would come from here, it will go here, and again if they both are not working, so there would be no working at the end, and there would be no output at the end, our system would be failed. Okay, so that's why we have taken these two parallels as first parallel not working, second parallel not working. So the possibility, not the possibility, this must be the condition for our both the parallels. Okay, so our both the parallels must be working. Okay, got it? What we say now, our both the parallels must be working to see to get our system work, so that we don't get the failure of our system. Both the parallels should work. So that's why we have say first parallel not working, second parallel not working. So both should work to get our system work. So that's why we have failure of the system. Failure of the system can be done by these two conditions: if not working, if this not working, or if this not working. So we have drawn it as OR gate. Okay, we have put OR gate here. Now what we say, first parallel not working. When we say the first parallel not working, what we have in first parallel, we have A and B, right? We have A and B, and we say first parallel not working. So if A works and B not works, so it doesn't matter, because you remember in parallel it is we should have one component work. If the other doesn't work, it does not matter. If the other won't work, it doesn't matter, because in parallel if A failed, so the input can be drawn from B, and if B fails, the input can be gone from A, can go from A. So got it? Yeah. So that's why A and B, and to represent this thing we have drawn our AND gate here. Okay, so to represent this thing, that if A fails, B can be gone, and if B fails, A can be gone. Okay, the input can be gone from A. So we have drawn it with the help of this AND gate. The AND gate would represent this thing, that either one is failed, the other is working, so our system will work. And either if the above one is failed or downward is working, so our system is going to work. There is a possibility of system of two works. And the same here also, we have second parallel not working. So if C not working, the input can be drawn from D to the endpoint, and if D not working, the input can be drawn from C to the endpoint. So here also it is not necessary for the both to work, only one component working is okay, is enough for us. Okay, so we have drawn this thing as AND gate C and D. So that was the way of describing, of drawing the fault tree analysis of our parallels, two parallels, the failure of the system. We have RBD of two parallels and This is the method, this is the way of drawing our fault tree analysis. Okay, and how we can further write it? We can further write it as probability is P of A, P of B, P of C and P of D. Okay, you know that probability is basically the products of P of A, and what this is? P of A not working, P of B not working, P of C not working, P of D not working. So we have first parallel. We say what we have, our probability of first parallel A and B. So P of A not working, P of B not working, and the probability of second parallel would be P of C not working and P of D not working, right? And we can say the overall probability of the system would be 1 minus PF of P, probability of first parallel, 1 minus probability of second parallel, and this is the probability of our top event, because we have this OR gate is present here. So we have to write the equation, the probability for this OR gate. So we got our probability of top event, that is 1 minus, you remember for OR gate how we can write it? For OR gate we have 1 minus x1, 1 minus x2. So there it is the 1 minus and the product of all I going from 1 to n. So that's why we have written this 1 minus probability of first parallel and 1 minus probability of second parallel. So we have written this in the form of like this. So that was for first. I explained you the first question. Now we'll move on towards the second question and the second system. What is the second system here? What we have the second system? See, the drawing is present here. We have a downstream, a water basin. Okay, we have a water basin in which water is present here, and it is being connected to a valve, and we have a valve A here. Okay, and it is connected to a pump, and we say this pump P is present here, and it is going upward direction. And what we have now, we have an upstream is present here. This is also a water basin. So the water is going from downstream to upstream. This is basically a simple system of the water that is going from downstream and to the upstream. And what are the passage of that water going from downstream to upstream? We have a valve here, and we have a pump here, and we have here B and C. What these B and C are, they are basically the valves. Valve B and valve C is present to get this water in our upstream, to get this water down in the upstream in our basin. We have two, this is present. What are these? Two valves are present, valve B and valve C. So this is basically our system. It's a really easy one. The water is only going from down to upward, and this is the method. This is the system of going our water. Physical system, you can say the physical system. Okay, the external parts of our system, right? These are the external parts of our system. Like externally this is happening, that the water is going from down to up, and the valve A is present and pump is present, and then two valves are again present so that water get easily down. It can also go from here, it can also go from here. So this is our basin, down basin, water basin, upstream. Okay, so what is our top event now? First we describe our top event. We say that our top event is no flow of water upstream. So what happens, what we say, if we say that our system has failed, what it means that our system has failed? Obviously when our system fails, when there is no water is coming in our upstream, the flow of water has stopped, so that we will say that our system has failed. Okay, so let's see how it can be represented. So what is the possibility of our getting our this system failed? Why this system is going to fail? Why the water has stopped flowing? So the possibility can be either these B and C are damaged. Either they both are damaged, so that's why no water is flowing here, or either the other possibility is that no water is coming from the previous things. The pump B and valve A are not getting any, they are not providing any water to B and C. So what would be the two possibilities? No flow of water in B and C. So how can be no flow of water in B and C? No water is coming from pump P and valve A, so that's why there would be no water flow in the B and C. And the other possibility can be B and C are damaged, closed or full. Either there is an error in they both B and C, either they are damaged, full, or either they are failed, or there can be a possibility that they don't have water in them, or they are not getting the water from pump P or valve A. So this can be the two possibilities. So that's why we write here no flow of water in B and C. B and C are damaged, closed or full. So that's why we say these possibilities in the form of, we draw it in the form of OR gate. Got it? And okay, now we have said that either there is no flow of water or either they are damaged. So first we see that why there is no flow of water. Because no flow of water is because there is no water coming into them. And why they are not coming to them? What is written here? Either valve A closed, either this valve A is closed, or either this pump B failed. So there can be error because we say that here we have pump B and here we have valve A. So either this is closed or either this is failed. Okay, so why not no water is coming in B and C? Because either there is an error in valve A or either there is an error in pump B. So that's why we say that valve A closed or pump B failed. Okay, and again we can, now we have to define that what is the possibility of getting this closed or getting this failed. Valve A closed. So why it can be closed? It can be closed because, and we have to draw all these things, we have to represent all these things. Don't forget to draw the OR gates in between them. So we have to draw now, we have to say that why valve A is closed. Either it is failed, yeah, the very first thing, valve A is closed because either it can be failed or either there is loss of power supply. That means that we are not having any power, we have a loss of power supply. That's why we have having our valve A closed, because either it is failed or either there is no power supply or loss of power supply. It's not getting the required power. Okay, so that's why it has closed. So either it is failed or either loss of power supply. Okay, and what is the possibility of pump P failed? We also said that pump P is failed. So what is the possibility of pump P failed? Either it can also be either it is not started or either it is broken. So what is the possibility of getting it failed? That either it is not started, we haven't started our pump, or it has damaged or it has broken something. So that's why it's not working, it is failed. So we also say the possibility of pump P not working and pump broken. Got it? For A is closed because either it is failed or either there is a loss of power supply. We didn't wrote loss of power supply here because this pump P is connected to valve A. So the power supply would be coming from valve A. So that's why we have wrote a loss of power supply in valve A. Okay, got it? So this is done. No flow of water in B and C. We have write all the possibilities of no flow of water in B and C. And now we say, we talk about that we have, what we have? We say that B and C are damaged. Either there is an error in both of them. So in them, either there is an error in them. So we say either they are damaged, they can be closed or they can be full. So that's why they are not giving any water, they are not flowing any water in upstream in the basin. So what is the possibility of getting damaged, closed or full? Either valve B is failed or valve C not working. So either this is failed or either this is failed. This can be failed or this is not working. So there can be error in both of them. So the same we write here, not failed or not working. So we first took this valve B as failed. So we represent it as valve B as failed and we write it as we separate it. Okay. So it is obviously it is not the scenario that both have failed. Okay. This can be failed and there can be another reasons for this. Okay. If we say valve C has failed, so for valve B we have other options also, other possibilities. And if we are saying that valve B is failed, so for C we have obviously other options and other scenarios also, other conditions for this. So what we say valve B failed. Okay, we took valve B, we say that it has failed. Okay, it has failed. Now valve C not working. And why it is not working? There it can be another possibilities of it not working due to rust information or wrong active, it is not active properly, or mechanical error. There can be a mechanical error in it. Okay, there can be wrong active, it can be wrong active, it is not active correctly, and it can be rust information. So all these are represented by what? By OR gates. Okay, see, OR gates, but here only we put it as AND gate. Why we put it as AND gate? You remember above we do it this thing as in the form of AND gate when we say that either this or either this. Yeah, if this is working, no matter this is working or not, this working is enough. In the same way, either this is working, no matter this is working or not, this working is enough, this component working is enough. So this thing we represent it as in the form of AND gate. And same here, you see why we represent valve B and C in the form of this, because either this working or this not working, this working is enough, or either this working and this not working, this working is enough. Because look at the picture, as you look at the diagram, if we have this working, so and this is not working, so the water can be flowed from this, so the basin can be filled. Basin, there would be flowing of water in the basin. And the same way, if this is working, this is not working, the water can flow from basin C, from valve C, so the basin again would get water. So that's why we have represent either this working or this not working, or either this working, this not working, the system won't fail, there would be a flow of water in the basin. So that's why we have represent this in the form of AND gate. Okay, now you got it. Now you got it why we, when we draw an OR gate and when we draw an AND gate. Okay, I hope this is very much clear now. So that was all. We have write all the possibilities. Now what is our goal is to our goal is to write numbers, to give numbers to them. So we write valve A failed. This was valve A failed, first one. So we write it at x1, and the other we got, you remember, here it is coming from here and here and here. Okay, and we say this as x1, and we say this as x2, and we say this we say this as x3, and we say this as x4, and this is x5. Okay, and this is x6, and this is x7, and this is x8. Okay, so we have named all of them in the form of x, because we have to write it as xi. So we have named them from 1 to 8. Okay, axis from 1 to 8. Now what's next? What we have? Okay, now we have named them from 8, x1 to 8. So we can write x9 here. What x9 becomes, it is basically these are all connected, this and this and this, they are all connected in the form of OR gate. So that's why we can write it in the form, in the way the OR gate is being represented. How we write it? So this is the product x1 to 1 minus x1, product 1 minus x2, and 1 minus here. Okay, and these both will be given in the form of products. You see, 1 minus x3, 1 minus x4. Okay, and x10, this is done. And now we can write this also in the form of x, and we name it as x10, and x5 is here, is an AND gate here. Yeah, so this x5 is going to multiply because it is from the AND gate here. Got it? And the rest is this x6, x7 and x8 would be represented in the form of OR gate. So 1 minus x6, 1 minus x7, 1 minus x8. So x5 into 1 minus x6, 1 minus x7 and 1 minus x8, because for OR gate we have the formula xo equals to 1 minus the product of i's going from 1 to n, 1 minus xi. So here we have the formula for the OR gate. So we just have written it in the form of like this. And the last what we got a last term, that is x11. That would be 1 minus x, 1 minus x9 and 1 minus x10. Why we wrote it? Because we have this thing, we wrote it in the last. X, we name it as x11, and this can be written 1 minus all this 1 minus x of 9 and all this 1 minus x of 10. So this is our final equation. So this was all our system. The system, that name was no flow of water in the upstream. Okay, in the basin, in the water basin, no flow of water. So we have drawn it like this. Now what we are going to do, I know the video has been gone a lot lengthy, but just to clarify more things to you, I want to discuss another example, so that I know that this one was enough, this was enough, but I have another example for you just to clarify things much more. So what we have this example, let's have a look instead of wasting more time in other things. Let's have a look what we have, another example for this. And what we have now, it's just a little easy and a short one, not a quite detailed one like this. Just in this example I'm just going to draw the tree, fall tree. Okay, so let's see what we have. We have a drum here, we have brake shoe, line, and here we have a switch, that is on off switch, and we have electromagnetic solenoid is present here. This is electromagnetic solenoid, and we have a drum here, we have locking nut, and we have a brake shoe. So this is basically the drum. And what we say, what is our top event? That we say that our brakes fail and they have stop motion. Okay, so what happens, what is the top event of this diagram? Sorry, the error in between, that was my battery error. So the diagram, this diagram shows that we have a top event. What our top event is, that for this diagram we have our top event, that is brake fails. So when brake fails, what happens? Our system stop motion. Okay, it has stopped to work, there is no motion happening, it has stopped motioning, and because due to our brakes that are failed. So what are the possibilities of getting our brake fail? Okay, when brake fails there would be no motion in the system. And what are the possibilities of getting our brake fails? Obviously we draw it in the form of OR gate. And what are those possibilities? Either excessive path wear, okay, or brake shoe not applied. So this is the separate possibility, it is the excessive path wear, okay, or either our brake shoe not applied. What can be the other possibilities of our brake shoe not applied? It can be that either bearing failure, or either the solenoid has not powered. Yeah, the solenoid is present here, electromagnetic solenoid, you can see. And here is it is a switch here, on off switch. So we say that it has not powered, or it has not been assembled correctly. So either they can be a bearing failure. Yeah, you must be aware of all these terms. Excessive path wear, either there can be brake shoe not applied. Why? Because either they can be a bearing failure, or our solenoid has not powered, or the solenoid is not being assembled correctly. So uh, what can be other possibilities of not powering? Solenoid not powered, so what can be them? There can be a winding problem, there can be a problem in the winding, so the winding has got failed, or there can be human error mistakes, or there can be switch has failed. So this switch, you can see this switch is present here. Either this switch can be failed, yeah, or either they can be human error mistakes, or there can be a winding failure. So that was when the solenoid has not powered. So there can be three possibilities for this solenoid not powered. So okay, so this is the method. This was the method. It is a short one. For our brakes that has stopped to motion, brakes has failed, and we name the first one as x1. This is bearing failure as x2, and solenoid has not powered as x3, and solenoid has not been correctly assembled is x4. This is our winding failure is x5, human error mistakes is x6, switch has failed is x7. So we have 7 possibilities, 7 probabilities present here. So that was, I hope they are all represented in the form of OR gates. Yeah, okay. So that was all for now. This topic has been finished, and I hope that you have understood fault tree analysis. I have explained you in the much lengthy form and much clearly. Okay, and if you want to ask anything, if you want any further information, or you want to ask any difficulty in this part in this video, you can ask me from comments. Okay, and that's all for now. Thanks for watching. Okay, bye bye.